Thank God. Thank God you reminded me. I'm recording the class now. So we are starting the class recording from here. Right? For those that will go back to watch the video of this class, next week, no excuse. That means you did not watch recording. Next week, whoever does the assignment with the smallest error gets 50,000 naira. Right? So that's the first thing that you'll be here when you start playing this recording. So it's on you. Well, wait, hold on. So that you're going to go and watch it at the wrong week. What's the date of next week? Whoever does the assignment, today is the 7th. Whoever does the assignment on the 7th of September, on the 14th of September, gets 50K. Right? So yes, someone said something now. I got distracted because I had not recorded.
I
Someone
said,
said, yes.
I said the link you sent now in the Q&A,
Yes.
I cannot use it because I'm attending the class with my phone. But if you
Oh,
send this link in the Google Classroom, I'll be able to use it from my laptop.
Okay, no problem. No problem. So usually the link should be in the, I'll add the link to the PowerPoint. You understand? So everything will just be there. All right, so no problem. Let's go. So now, in the link in the Q&A, this is where it will bring you to download this data. Just come to this part of the data, and you will see download. So we have downloaded it. You will see bostonhousing.csv. I have one because I've downloaded it before, but Boston Housing CSV. So we have the data set. Now, this data set, we have it because it is cleaned. It is what? Cleaned. So we will just assume that, okay, don't let me take you through the rigor of cleaning the data set. Let's assume we have a cleaned data set. We just want to build a model on it. Let's do it. Let's see what it looks like, right? Let's see what it looks like. So I am here. So now, so we have the data set already, right? We have the data set already. What do we want to do? Let me first take you through what NIME looks like and the possibilities NIME. NIME is made up of something called nodes. There are nodes. Please, I'm going to be moving very fast. If you have questions, please let me know. I am going to be moving very fast. So, how do I leave here? Yes. Let me know. Ulrich, you raised up your hand.
I did. So
yes.
So I did. So I have NIME downloaded. I'm at the welcome page. So which
Create a workflow. You see, create workflow.
Let's
it will
see.
bring something by
Yep.
default that's
Okay.
NIME_project. You can change it to any name you want, and then it should take you to the interface you're seeing now.
Okay.
Yeah. Okay. So please, if you have any question, I'll be checking here intermittently. Just raise up your hand and then let me know. And if you feel that I'm not answering your question in time, maybe I'm leaving you behind, drop a message on the Q&A. I will see that much more faster than I will see your hand being raised. All right. So now let's go into NIME. Now, if you are joining NIME for the first time, if you are opening it for the first time, it is advisable you come to preferences. When you come to preferences, you will see something called NIME Modern UI. NIME Modern UI. By default, it will be on the starter nodes. You want it to be on all nodes. I hope I'm making myself clear. By default, it will be on starter nodes, but you don't want starter nodes, you want all nodes. Starter nodes means you won't have access to all the nodes that has been pre-installed, right? So you want it to be on all nodes. So go to your preferences. I'm using a Mac, that's why you can see it, but in Windows is a bit different. So go to NIME, instead of starter nodes, go to all nodes, and then boom, or apply and close. Make sense? Good. Now, look at, so there are different nodes that are categorized into input outputs. So this deals with your inputs and your outputs. How do you read a file? How do you write to a file? This requires manipulation. There are different nodes that are already written for us. They require manipulation. This requires graphing. How do you want to write the graph of your stuff? Analytics. If you want to do some machine learning, this comes from machine learning, some predictive analytics. If you are dealing with databases, this is another one. If you are dealing with different data types, date, time, right? We're going to work with, you don't need to cram, you don't need to be worried that, Egbami, hey, see all these things. No, don't worry. They are all useful nodes. And if you've downloaded it, you can also activate your 9 AI assistants, right? Right. I have mine already, activated. I just need to sign in, and then, voila, it will just sign me in, right? So you have your own 9 GPT, right? Your own 9 GPT that will, how can I assist you today? What is the node for linear regression? This is the first time I'm trying this, right? Yes, so it is telling you that the node for linear regression is this. Do you understand? So you have your GPT that can help you in case you're like, oh my God, there's all these nodes. Which one should I look at? You can go to the GPT for 9 and ask questions, right? Don't worry, it's fine. Yes, so we are back here. We have different nodes. We've changed preferences. Please, any questions so far? Any questions so far? Said, are we on the same page? I've not heard your voice. I don't know what you sound like. Obina, Nuruddin, Ali Balogun. That name is muscular. Mohammed, Meshak, are we good? Is it that this one? If you don't have any question, is it that I'm a very good teacher or you're a very brilliant student? I know you're a very brilliant student, but you should have questions. So someone is talking or doing something on their mic. Someone raised up their hand. They haven't raised it too. No problem. So let's go. Let's go. So now, the business has a matter. And what is the matter? They said that, we want you to predict the Boston house prices for us. We're like, okay, give me the data set. When you downloaded the data set came in CSV format. Can you see it? CSV format. So what does that tell you? When you come to 9, that means you need a CSV reader. You need a what? A CSV reader. What if they had given you Excel? It would have been an Excel reader. What if it was a Google Sheet? It would have been a Google Sheet reader. We can show all of them. You understand? What if it has been an ARFF? You would have needed an ARFF reader. For you to see if it was a PMML, you would have needed a PMML reader. That being said, all that they gave us was what? It was a what? You can also search for it if you know it, a CSV reader, right? In the CSV reader, you can see there are 3 statuses. There's red. In all the notes, there's 1, 2, 3. So red means you need to configure it. Yes, somebody is making a sound. Any questions? Any questions? Any questions? Okay. So you need to configure it. What do? I know some of us here, we are already professionals. We already know this part. We're going to browse. When we browse, we'll go to the folder. My own is in the downloads. We'll go to the folder where the data is, Boston CSV, and you open it. You go to configure. Now, if you look at, it was red before, now it is yellow. It is yellow because you have attached the file you want it to read. And the role of this is just to read a file. It's just to read a file. And now it has read it. It has read the crime rate, the zone, the this. It has read everything. It has even read what you want to predict. Now, what you want, look at the summary of the table. The summary of the table is telling you that this table has all these columns. It has all these columns. What are the type of these columns? They are what? Some of them are double. What is double? Double is like floats, and they are like what? Numbers that have decimal point, like 0.066. So if I come to this table and I look at cream has decimal point. Zn has some are integers, some are decimal, some are integers, some are decimal or double. So double will always override integer. So that's why to say double. You get. Now some are integers like rad. If you come to RAD 1, 2, 2, 3, 3, 5, 5, they are what? Integers. There's no double across all of them. Right? So that's what this statistics tells us. It tells us that This is the variable types for each column. Now, does any of them have any missing values? None of them have missing values. What is the lowest value in this column? This. What is the maximum value in this column? This. In criminal crime rate is between 0.06 to 86%. This just shows what is the mean in the column. This just shows the statistical attributes of that Excel document. Make sense? Hello? I feel I'm talking to myself.
Not at all. You are good. You are good.
You're good. Anna, can you unmute? Can you tell me everything I've said? Hello, Anna. Hey, and Johnny, you raised up your hand. And Johnny, I'm on mute. You can unmute and talk.
Hello, sir.
Obina, you raised up your hand too. Yeah. Someone is talking.
And Jory.
And Johnny.
Not all of us are activated to unmute.
Yes, I have activated you now. You can unmute. Yeah.
All right, thank you.
Yeah, you raised up your hand. What's up? You want to talk? You want to tell me something?
You mean me?
Okay. Yeah,
That's
you
just,
raised up your hand.
That's just the remark. That not all of us.
Okay, no problem. Meshach. Said. So I have 4 people raising up their hands. Meshach, you can talk. Egbam. Oh yeah.
Hello, sir. Yeah.
Yes.
Good evening, sir.
Good evening.
Yeah, my network. I think I had a problem with my network. The manager, so he's fighting me. So that's why I can't connect most of the time.
Okay.
So okay, I'm in the class. I've downloaded and I've installed, sir. I'm just trying to catch up with the class.
Okay.
I've downloaded everything.
No
Yes,
problem. No problem. That's
all
fine.
right. Thank you, sir.
You're welcome. Ogogo, you raise up your hand. Ogogo, breakfast. Hello, Said. You've unmuted. You can talk.
Can you hear me now?
Yes, I can hear you.
Okay, good. Sorry, I think I was having a little challenge on my network.
Okay.
One observation.
Okay.
I'm connected to the phone and also connected to the system, but I observed that on my Q&A on the system is only showing my message. It's not showing any other messages. I can't find the links. Nothing is showing, but on my phone is showing everything. Yes, so I don't know what is happening. I try to refresh. The issue still persists.
So I'm going to.
But
I'm
install.
going to. So if you look at this is saying broadcast to all. If you can look at my screen, I'm going to replace.
Yeah, I can see. Yeah, good. I can see it now. It's just showing up now.
I'm going to also paste the one of Nime. I don't know if you had it before, but I'll paste all relevant links for you to,
Thank you. I appreciate it. Yep.
No problem. Thank you.
Yeah.
Thank you very much. So other people, so yes. Ugo Chukwu.
Okay, yes. I was trying to I wanted to know the process of installing the data in the app, but I think I found it.
You found it, Abby. So you come to CSV Reader, you configure. When you configure, you browse to the directory where the file is saved, right? And mine is saved in downloads, Boston CSV, and then boom, that's it.
Okay.
Right. And then once you do that, you apply. Okay. It changes status. Let me reset. It will change status to yellow, and then you execute. You can see a run button. Execute, and it reads the data. Right. So that is Ugo. Ugo has been solved. Said has been solved. Orich?
Yeah, it's a little bit kind of like the same question. So I was able to search the CSV reader. So if you could walk through this again. So once I select the CSV reader, how do I go into my directory?
So you can see when you put your hand on the CSV reader, some buttons show up on top. Buttons show up on top. You see one that looks like settings. That means to configure. If you click on configure, a window will pop out, and then you will see browse, right?
Okay.
Browse will take you to the directory where you save your data, and then boom, you can now go through. Make sense?
Okay. Cool. You just need to. Okay. Got it. Thanks.
Yeah. Okay. Next person we have Ogogo. Are you there?
Yes, sir. As you say, we should download the AI account. I tried to download it. My system is hanging since I cannot even stay hanging. I'm struggling
That's
to.
because Nine know that if you have that assistant, you become lazy. Well, just quit it, reload it, don't touch the assistant. Please don't touch the assistant. Nobody should touch the assistant. Hey, Joe, don't let your system crash. That was just a joke, right? Maybe it's because of the capabilities of your system. So for now, let's just leave it. It's let's just leave it. We can use the default chat, right? Don't bug yourself. Make sense? Don't stress yourself. So just quit your Nime and restart it. If it's frozen, use your
Okay, sir.
Makes sense. Okay. Thank you. Meshach.
Are you calling me?
Help us mute.
Yeah, you call me, sir.
Meshach. Yes, your hand was raised.
Yes.
Okay.
Yes, I just said I've been able to upload the data already.
The
now.
CSV, very good, very
just
good,
like
very
what
good.
you've instructed me.
There's some. Don't worry. After this, no problem.
With the node part of it.
Okay, no problem. So Meshach is done. Josephine.
Yeah, I've downloaded the name, so I'm following.
But Josephine, you told me you were watching the video. When you were watching the video, I told
like since the
Nine
first class.
download was part of the video.
Yes, I've downloaded the name like in the first class, so
All
I'm
of
not
you,
really.
no. I think at this point I will pass more. All of you are treating this class like as if it's Sunday service, where it's only when you go to touch you touch your Bible. You are treating this class like a Sunday service. For some of you, you just on the video, hear my fine voice, and that's it. I know my voice is fine. No, but yeah, you need to practice. It will be evident. In short,
Sir,
I will be
you're not
feeling
lying.
it when you are
You are not
practicing.
lying, sir. I watched the video and I did not even follow. I watched it. I will not lie. As you said, hearing your fine voice, that was actually what happened. Let me not lie, sir. And I'm sorry.
No, actually, I'm actually following you. Like my name is opened on my laptop. Though I'm
The only way you can follow me is by doing the work, by their fruit. You will bear fruit on 9. You are supposed.
Okay.
I expect people to come and bamboozle me and say, "What is PMML? What is PMML? What is logistic regression?" I read about because this is where you will know. Let me tell you something. Everybody in this room, in this class, across the classes, will know of 9, but only few people will stand out as the best users of 9. Only few people. It's not about knowing it. And 9 exists. And you know, in the next 1 year, be like, "Oh, you remember that class that we did? And we did it too." Some people will be there. It's not a lie. But some people will be like, "Oh, 9. And the workflow is before they even get the data, they already know the workflow they will use. They already know the hyperparameter they will do because they are practicing. You need to practice beyond this class. This class, you people are just making it easy. I can just wake up 10 minutes because I know the first one now we are going to go over the other class. I can just be on serious. 10 minutes, I just do. You are making me on serious. You are influencing me. Koda. It's not good. Josephine, see how you want to influence me. Josephine on mute. This is how you want. This is what you want to leave. The legacy you want to leave with me. I'm just meeting you for the first time. This is what you want to leave with me, Josephine.
No, actually, I don't understand. You asked us to download the data set. I have the data set, and my name is open.
Since last week.
I've actually been doing. Okay,
Next week,
what question?
I
What
will
question
know.
should I be answering first?
Josephine
Maybe
looks
I
like
didn't
the
get your
child of a
question.
rich. Josephine, you look like a child of a rich man. So 50K may not be your. Doesn't matter.
Well, okay, what question am I supposed to answer? Because you said that we following. I said I'm following.
Yes, but you say you just downloaded 9, which shows that
No,
when
I
you
didn't
got
say
it,
that. Like I said, that I have downloaded 9. I downloaded it from the
Okay.
first class.
I misheard you. I apologize. No problem. We'll see. No problem. So Josephine is down. Anna Duncan, you raised up your hand.
But see, that was before.
That was before. Okay, no problem. Ayobami, you raised up your hand. Okay. Kenneth, you raised up your hand. Nuruddin, talk.
Hello, can you hear me?
Yes.
I've downloaded that. Okay.
No.
Yes.
Okay.
I've downloaded and installed 9, but I'm struggling to download the data sets.
Yes. Do you have the data set? Have you clicked on download? Do you have the link?
Yes.
Have you clicked on download?
Yes.
Is it just your network issue? It may be a network issue, right?
Okay.
So just wait. Yes. Ayobami, you can hear you.
Yeah, I said we have downloaded this everything since the last 2 weeks. Are we still working on the same data today? That busting.
There were new people that joined today that I want to brush through. So I plan to use the next 30 minutes. And if you people are willing, I will extend the class today by maybe 30 to 45 minutes so we can do the extra thing we want to do. So this will be a revision for you. Yes. Who is the person talking? Show me. Did you do your assignment? Hello? Who is the person that?
Hello, sir.
Yes. Did you do your assignment?
Yeah, I'm sorry. I'm joining the class for the first time. I was
who is
not
the person
around.
that said that? Are
I
we
just
doing
and I need to join the class.
Who is the person that asked me about busting? No.
Hello?
Yes. Who is talking?
Hello.
Who is talking?
Good evening.
Yes. Kenneth.
Okay, good evening. Last week, I'm still having challenges on this AI concept. I need to understand the AI concept. So most of my time last week was spent studying AI system.
That means you know AI system very well now.
Yeah, I have the fair knowledge that so I cannot follow up because that's why I not do my assignment. But I'm showing
you did not do your assignment because you were understanding the assignment. No problem, it's fine.
Yes,
no
problem. I don't do data and copying, but I don't know what I'm doing. So I need to grab what I'm doing so that I can have confidence to speak that I know.
Very good.
AI.
So that means you do it next week, Abi? No problem.
For sure.
Okay, we're on the same page.
Sorry.
One question again. This data set, where do we get the data set from?
I pasted the link on the chat. Link on the chat.
No, if I want to generate the data set, for example, I would like the data set.
Oh, we will get to that. That's why if we're not going back, we would have gotten there. How to know your data set, how to engineer your features, you would have known it. But don't worry, we'll get there.
I have some IoT system that generate data. Power system is can monitor my power system on my different devices. But the data does have only 3 variables: voltage, current, and power.
We can talk about that later so that the rest of the class can catch up. Yeah, we'll talk about it.
So I'm very, very interested. I will do my
problem.
One at a time. We'll get there. Thank you.
Yes, no problem. Adoga, any questions before? I think we've taken enough break. Any question?
Mine, can you hear me? Mine is not a
Yes, I can hear
question.
you. Okay.
Okay, lovely. Mine is not a question. Anyways, thanks for everything you've been doing. Mine is not a question. It's more of so even before you mentioned the assignment, when I was doing my own personal reading and trying to understand the whole K9 thing, I sat down the data sets with the diamond data sets, and I got a mean square error of 0.006.
Okay, this is for the assignment, Abby. Don't worry.
I didn't know that was the assignment. I was just doing it on my own. I was just working on my own. Like I just need to understand it properly. So that was just me working on my own. And then
no
I went
problem.
back to the
We'll come back to it. So that means you are way ahead of the class, right? You are way ahead of this class at this moment. In the next 30 minutes, we should have reached where you are, and then they'll get the assignment, and we will do the additional thing you have to do today, right?
No
so
problem.
we have to meet status quo. Ayobami, last question. Ayobami, you can unmute.
Yeah, my question is I have a little problem with the channels we are using. I think most of the, like today, I would find it difficult to get the link to the class. It's like most things are done on the Telegram. Well, I think we should, especially me, I'm a WhatsApp person. I don't know if we can tilt a little bit more to WhatsApp or something so that we can follow up some. Yeah,
I'll talk to the admin, and then we'll see what we'll do about that. No problem. So thank you very much. Right, so all this has been cleared. Okay, so now let's quickly do Boston housing, and then let's go. Now, if you remember what I said about cultivating intelligence, right? You want to, let's assume that this Boston housing, you want to learn simultaneous equation. Now let's assume that this is the old data set. So this is the syllabus, right? This is the syllabus. Now, what's the first thing? As a teacher, some of us have thought, what will you do? Right? You will first what, split the syllabus into, these are the ones I will give them for examples. These are the ones that will be their tests, that will contribute to their continuous assessment, that will be their test and their exam. And for us to split it, we need something called partitioning. Right? We need something called partitioning. So I'll take this data set. If you look at this data set has 506 rows. It has 506 rows and 14 columns. Now, if I partition it, right, I want to partition it into 70%. So 70% of the syllabus will be taught to the students, 30% will be used for their test and their exam. That's what this is telling me. So by the time I execute, if you notice, it has been split into first partition and second partition. First partition is 354 rows. Second partition is 152 rows. So this will go to, their continuous assessment. This will go to their test and exam, right? Then what's the next thing I want to do? Now, what am I trying to predict? So our model, we see this data for training, and I want to predict MED-V, median value, as the output. Now, if you look at what is MED-V, MED-V looks like a double. So we are predicting continuous value, so we can just do regression. So let me look at all the regression nodes that exist. I can just type regression, and I can see all the regression nodes that exist. Let me just do a very simple regression, linear regression, right? Linear regression. So I'll take the first partition. Now, your learner, if you see, it's called a learner. That's a student. This is the student you want to train. You give him all the test and exam, and you evaluate. Let it run. So by the time you run, you've already taught it. Now let's configure it. Now, when we configure it, this is the target value. We are saying that this is the target value is what we want to predict. If you look at this target value, it's not going to be here. So you have, if it was here, you can change the value. If it was tax we want to predict, if you put tax here, if you notice, tax will be taken away from here, right? But we want to predict MED-V. By default, it always takes the last column by default, but you can change it, right? And then these are the features, other features. So you click OK, it's going to reset itself. When you run it, it has predicted. So the student now, after the whole semester, after first term, We already know it. You have taught us, you have taught us, you have taught us. They already know it. What do you want to do? We want to set an exam and give them an invigilator. There's something called regression predictor. Regression predictor is an invigilator. So the other part of the syllabus that is for test and exam, you bring it here. You take, this is the student, you bring the student's knowledge, you bring it here, and then what? You can see it's going to create another column called, this is what they do. When I gave them the exam question, oh, this is how they passed. This is how they performed. So if you look at the table, there's MED-V, and there's prediction MED-V. Do you understand? There's MED-V and there's prediction MED-V, right? So when we said 5, it predicted 8. When we said 8, it predicted 4. When he said this, so now this is their answer sheet. This is the answer sheet they've brought. We now want to evaluate their score. What is their score? There's something called numeric scorer, right? Numeric scorer will predict what they have and the actual value, and it will compare it. So you take the student after their exam sheets, you come and configure and say, what do I want to compare? I'm predicting the predicted value is this. The reference value is what? MED-V. I'm taking MED-V. I want to predict it. Okay. What is the value? Right? What is the error? You know, we are measuring error. Error is supposed to be smaller. The smaller the error, the better. The error is about 3.6. The error is about what? 3.6. That means that if it says 5, the error can be plus or minus 3.6. So 5 can be 8.6 or 2.4, right? 2.4. Do you understand? Now, let's plot it. We can come to line plot. Let's plot it, right? Let's plot the values. When I say plot, I mean let's plot. So all the things I don't want to plot, I can move them here. Let's plot how it is seeing MED-V and the prediction together. Let's plot it, all right? If we plot it, we can see that the blue line is the actual value, while the green line is the MED-V. You can see that they are very close to each other. It's just a simple linear regression. So far, any questions? We have done a model, and this is the output. You just take this graph and you go and give it to your boss and say, I have a model. The error is what? The error is what? 3.6. These are the attributes of the model, and that's it. Any questions? Here I am. Ulrich, you can unmute.
Yeah, so Tolu, don't mind me, but I'm a little bit behind. So I went onto the first I followed the linear regression, but I did not select the MED-V column. So now when you select MED-V, right, and then you apply linear regression, is there anything else that I need to focus on to go to the next
did this turn
step?
to green? Did this turn to green?
Yeah. One
So
second,
you
let me
bring
click OK. So 1 second, let me click OK. It is green. Yes, it is green. Yeah.
So you
Yes.
bring the regression predictor, you pass the knowledge to it, and you pass the data to it. And then
So
that's
now
fine.
regression predictor.
Predictor, numeric scorer, and line plot. All right. So just look at the screen, follow the chart and everything. Any questions so far from any other person? I know this is something we've done. Ugochukwu.
Oh, yes. So when you say knowledge,
yes,
you say you pass the knowledge. What exactly is this knowledge?
Very good questions. So if you look at a linear regression is a straight line. The equation of a straight line is y is equal to mx plus c, where y is your dependent variable, x is your independent variable. What does that mean? X is your input, y is your output. But you are looking for constants, m and c. M is your gradient per variable, and c is your y-intercept, right? It's just a straight line. So in this scenario, right, we have all these variables. If you can see it, you can see intercept too. So let's say this is x1, x2, x3, x4, x5, x6 to x blah blah blah. So your equation is going to be y, med is y, is equal to m1 x1, m2 x2, m3 x3, m4 x4, m5 x1 plus intercept. What is that m1? Your m1 is this coefficient. These are the coefficients. So this is the knowledge that you are passing. That using this knowledge, using this coefficient, form a line across these new variables. And that's what is giving us this score. That with those equations, this is how terrible the model is, or this is how good the model is. If I pass another data in, so say for example, I want you to take note of this first variable, this first coefficient. This is minus 0.083, right? I'm going to try something now. This partition, I'm going to configure it. Instead of 70%, let me change it to 75%, right? If you look at it, will reset everything. Everything has reset. The learner has reset, this has reset, everything has reset. By the time I run this and I run this, the knowledge has changed. The coefficient is now 0.091. Now, I don't know if it will make the model better or worse, right? But when I come to the scorer, he made it better because it was 3.6, now it is 3.2. Do you understand? He made it better. So the knowledge is better compared to before. So usually this knowledge or this coefficient will change over time. Every training will lead to a new variable. Am I making sense?
Yes, you are.
Thank you. Thank you very much. So now we've been able to train our first model. Let's move very fast. Let's move very fast. I want us to be done latest an hour. Right? So if we understand this, now there's something that I used to teach. I'm going to copy and paste the same thing. Right? Copy and paste the same thing here. Right? If we understand this, now there's something in analytics. So we understand the concept of cultivating intelligence and how we've applied it. How we learn from SS1 in this class. They give us the syllabus, we take into classwork and homework and test and exam. We train the student, and when we train the student, we give them an exam, and depending on how they perform in the exam, we can promote them to the world or to do their JAMB or their GCE or to promote them to SS2. Make sense? Makes sense. Now, I want to teach you the concept of normalization now. Of course, for some of us, for many of us, it's no longer new. Normalization. Right? Normalizer and normalizer. Apply. Right? Now, let's assume that we have a data set. The data set is 2,000, 3,000, 4,000, and 5,000, right? Let's assume we have these data sets. Now, let's now assume that one person, they were sleepy, they were sick, human error. Instead of 3,000, they wrote 3,300, right? Instead of that, they wrote 3,300. So that means that the clean data, the data without error is what? This. The data with error is this. Now, what is the value of the error if I subtract them? The value of the error is of magnitude 300, a whole 300, right? So far, any questions in the concept I'm trying to convey? Any questions? Hello?
Sorry, sir.
Yes.
I think your system, okay, yeah. It went to hibernation or something. We are just in your desktop before.
It was network, probably.
Okay.
Duncan, Anna, you raise up your hand. Anna. Okay. Ugo, is this from before? I'm seeing your hand is raised. Is this from before? Okay. I guess it's from before then. So now, the concept is, 2,000, 3,300, 4,000, 5,000, then 2,000. Now, what's the magnitude of the error? The magnitude of the error is going to be what? 300. This is why we normalize. Now, one concept of normalizing is divide by the highest value in the data. So if I divide by the highest value in the data, let's focus on the one with the error. Let's focus on the one with the error, right? If I divide 3,000 divided by 5,000, that will give me what? Anna, are you there?
Sir?
Yes.
Yes, I can see you. Okay, it is back.
So you are looking at my browser. It's on my browser, right? Can you see my browser? Right? You can see
Yeah.
my browser. Yeah, so it's my browser. It's not my desktop. I'm intentionally on that scene. So now, if you look at 3,000 divided by 5,000, this is the true value. It's supposed to be this. But now, if I do 3,300 divided by 5,000, it will give me 0.66. Now, this is the value I will now use for training. So what does this mean? It means that the error that is 3,000, if I use 3,000 as it is, and I use 3,000 instead of the scale of 3,000, but it has somebody has added noise to it to be 3,300. The magnitude of that noise is 300. But if I normalize, the magnitude of the error will be 0.06. Do you understand what I'm saying? So I've brought the error down from 300 to 0.06. Do you understand what I mean? Does everybody understand what I mean? Do you understand why we need to normalize? Josephine.
Yes, I have a question. Just because you said that to normalize, you take the highest value,
No,
divide
that
by
is
the
one
highest
concept.
value.
It's not necessarily, there are different ways of normalizing. I just gave you an example of what to normalize, how to normalize. There are different formulas for normalizing. There's interpolation, standard scalar, power transformer, min max scalar. There are different
Okay,
ones.
there's a standard formula, because the thought just came to my head that if we just follow any rule, are we not trying to manipulate the data? So that is
Is data normalization, is data manipulation? Yes, but normalizing, there are different strategies of normalizing. Do you understand? The one I gave about this dividing with the highest value is just an example, just so that you will understand the relevance and importance of normalizing.
Okay.
Do you understand what I mean?
Yes.
Very good. We're on the same page. So
I have a question. I know you just said that there's many different forms. Assuming we decided that we would just look out for outliers and just remove the outliers, would that be a valid form?
So, but that if you would look out for outliers, what if you have 1 million rows? You can't get them totally, right? You can't get them totally. That is one. Number two is unless you are very, very, very sure. So what I usually do, which is the approach, is I train unnormalized, I train normalized, you train with different strategies and pick the best. Do you understand?
Based on the error?
Based on the error, yes.
Okay.
Makes sense?
Is this like one of your favorite methods that seems to work for you?
Is it the method of normalizing?
Yeah, the one you just did now.
No. So usually I work, and in practice I bounce between power transformer, standard scalar, and min-max scalar. Those are the three I bounce around off. Right, but we'll get there.
Okay, all right.
What did you say?
I was just gonna say, why didn't you use one of those here? But maybe that's more advanced than.
Yeah, no. We are in. If you look at this normalizer, if you look at it, to tell you normalization method, we have min max. So most of the times we are going to use min max. We have z-score, we have decimal scaling, right? So
min max is so when you divide it puts the number
that bounding. So if you are using min max, you can say I want my min max to be between -1 and 1. You can say between -5 and 5. So you are saying that you want to bound your noise and your variables between -5 and 5. So it will find a way to scale it such that the highest value is 5 and the lowest value is -5. Makes sense?
Well, how is that related to what you divided? I guess that's
so. For example, in the example I showed you, it is one between 0 and 1. It is one between 0 because I'm dividing by the highest value. So if I divide 5,000, the highest value will be 1. The
So
lowest
just
value.
you say, right. So because you put your minimum maximum around 1, did that I guess, was that logic? I don't know if,
Yes, that's what founded the basis of the logic of what I explained.
okay, got it. But
So,
that's
but
okay, all right.
yeah. So, but this does
Yeah.
not. It can be minimum can be between 0.1. You understand? Like it can be between minus and 10. All this is design choice.
And if depending on what you put there, it's going to divide by something else.
Exactly, to make your lower
Okay.
number that and your maximum number that. All right.
All right,
I can
got
decide
it.
to say between 0 and 0.1. It's going to limit all the values and all the noise between those constraints, right? So, any questions so
Okay.
far? Okay.
Please, can
Yes.
you just the process you used for your example? Can you just explain that again, just briefly?
So I said that let's assume I have a data set of 2,000, 3,000, right, and 4,000, right? 4,000 and 5,000. Now let's say this is what I gave my analysts. Let's say my analysts, because they are tired or they are watching Big Brother Niger or Premiership, instead of them to press 3,000, they press 3,000 or they spend 3,300. So now, if I compare the true value and the value with noise, the magnitude of the error is what? 300, right? Now, if I give my student this 300, this huge 300 error, it will confuse them, right? So, but if I normalize by dividing by the highest value, it's 3,000 divided by 5,000. The normalized true value will be 0.6. But the normalized value with noise will be 3,000, will be 0.66. So instead of me to compare 3,000 with 3,300, I'm going to be comparing 0.6 with what? 0.66. If I calculate the magnitude of the error here is 300, whereas the value of the magnitude of the error is 0.066, which is smaller. 0.066 is approximately 0. Am I making sense? So my students will, instead of them to see a magnitude of 300 error, they will see a magnitude of error that is approximately 0. Am I making sense? Right?
Yeah.
Yes. So that is why we normalize. That is why we what? Normalize. So now, instead of me to just direct this partition straight to the student, I will remove the noise. When I remove the noise, I will now bring it to the student, right? I will remove the noise and bring it to the student. I will ask, what are the things I want to normalize? I want to normalize everything. Okay. Right? I want to normalize everything. Now, for the test, the way I normalize, or the approach I normalize, I want to approach the same normalization strategy in the test. That's why I will take the knowledge of the normalizer and put it here. By the time I run this, and I run this, and I run this, and I run this, and then I run this, you will see that the value of the error. What's the value of the error? The value of the error here was what? The value of the error here is what? The hell?
Is it the 0.06?
0.084.
Oh,
Right?
okay.
Or look at them. This is the value of the error. Compared to the one without normalizer, 3.2, 26. This, not that. You can see which one is better. The one with normalizer, the one that is denoised. Right? Now, let's look at the graph. This is the graph of the normalized value. You can see how the graph is very close. Look at the graph of the normalized. Right? So let me open in a new window. And then this. Come here. Okay. Opening a new window. So look at it, right? Now you look at it. Now look at the array. See, the error here is 30 something, but the error here is 0.6. You can see the scale of the error is different. Am I making sense? Hello? Am I making sense? Is anybody there?
Yes, yeah.
Yeah.
Perfect. So we've done two things: normalization, blah blah blah. Oof, oof. Now there's something I wanted to try. Hold on, this is just for my own learning sake. Don't learn it all. Don't learn it all. Okay, let's see.
We follow the master.
I just want to try something. Now look at this 3.7. Look at this. This is what 3.2. Terrible, right? Now, what did I do? I was hoping to try it. You don't need to try it. I was hoping to try it. What did I do? I took out the prediction value. I only normalized the input, right? I took out the prediction value. Do you understand? So normally this is what we did. We normalized everything. So now let's try. What if we normalize between 0 and 0.1? Let's just see. Let's see if the error will be better. Let's see if the error will be better. The error is 0.00008, right? Let's look at the graph. The graph is okay, right? So there are different approaches. There are different approaches, right, to do it. So that is that. Now, what's the next thing?
I have a quick question. Sorry, I'm just a little confused. Which of those tasks is showing you the error?
Which of what is showing me the error? This
Are
is
you
the numeric scorer is showing me the error.
the numeric scorer?
Yeah.
But did you have the numeric scorer in the? You've not done
First
the
one.
diamond, have you?
Yeah.
Yeah.
I did it. I had it
Oh,
here. That's
I guess
what
I
I
just
gave me.
missed it.
Yeah.
Okay. All right. Yeah.
And so this is regression in a whole. Now, just
Sorry, I have
in
a
an
question.
yes. Who
I
is
have a
talking?
question.
I also have a question.
Dari. Yes,
The
okay.
fact that I have that the error in my model is very small, does it mean that the model is like, does it mean that model is good? Like, what if
Yes.
I had manipulated my data in a
Yes.
way that does it not mean that the model like
Yes and no. The answer
does
is
it?
yes and no.
So do you get
The
the
answer
question?
is yes and no. So yes, low error is good, very good, very, very good. But low error, sometimes 100% is best. If you give me a model that is 100%, as a machine learning expert, I will throw your project away. We don't want 100% because 100% means the model has crammed. The model has, like a student that cram. A student that cram and pass the exam. You have seen the question before, you have crammed it, you have passed the exam. And a student that know it, in short, they are getting 80, 70. But if you give them maybe something, they can reconstruct it for you. Which student do you prefer? Is it the one that got 100 that have crammed? Or the student that is getting 89, 90, but he can construct it and build everything for you? We prefer the one that can construct, right? Am I making sense?
Yes.
So when there is absolution, that means that model is called in machine learning, it's called overfitting. That model, that intelligence is very artificial. I know it's artificial intelligence, but that intelligence is, more cursive. They just pad it there. Once they leave the class, they will forget. We are like that. We are students like that.
Yes.
We know to do this class. Let's just cram it. As you enter the class, at the back of the exam sheet, you will write everything you just cram. You download. And some of us, in the class, will be like, hey, come on. You do formation and you get 100%. But when they now ask you, you got 100, come and go and do this scholarship exam. Come and compare. You say, I cannot do it. Do you get? Because, we update to cast, right? So that's
So what's the acceptable error level? Like, what's the
no, it's
acceptable?
That's why you are partitioning. That's why in your train and your tests. So now, let me give you an example. if I look at this one, if I look at this, this learner, the training year, this one is not showing me. The training year, let me look at this. Control C, Control V. Let me see this. Hold on. Hold on. So this is in this. Hold on. Yeah. Okay, let me show you this. I'm going to show you something now. What am I going to show you? Yes, I'm going to show you something now. Let's do this. Control C, Control V. I'm going to do this. I'm going to take this knowledge here. I'm going to take this training here, right? And I'm going to run it. I'm not going to bring a scorer. I'm just going to show you convey, bring a scorer, and I'm going to run it. What was the error? Like the error is what? What the hell is this thing? The error is what? The error is 0, right? The error is what? 0. Right? This is the worst model you can use in this exercise. Now, why? Why is it 0? If you look at the students, you know, all of us, we have been privy to all those lesson teachers that they will think they're helping us. Maybe our class teacher is our lesson teacher. So we that we are in their lesson teacher, they will give us the questions that will come out in the tests, so that we will beat the students in the class. We already know, we know ourselves, right? Now, if you look at this student, the data that they use to train it is now the data that they gave it in the exam hall. So me put it cram, he has crammed it. When he crammed it, it answered all the questions. If you look at it, answered all the questions very well. If it's 0.36, 0.37, very well. And so the error is good. But can I send it to the field? No. Because it is very good on data it has seen before. It will be very bad on data it has not seen before. Do you understand? So that means if I look at this error, if I look at that error alone, it is bad. That's why we have to partition. I will only evaluate this model on data it has not seen before. On data it has not seen before. And if you look at when you partitioned it, it was on data it has not seen before. If you look at the numeric scorer, it is good. Yes, small error is good. I'm hearing my voice. Ayobami, you can mute. Now, small error is good, but small error on data it has not seen before. So if it gives me a very, very small error, I will first go and check my data. Am I sure that there's no data leakage? It's called data leakage. There's no data leakage into my test data. If there's no data leakage, your model is good. That is one. Number 2 is this min max scalar. It gave me 0. It gave me very small error because my scalar, you can't just say 0, 1 to 1, minus 1 to 1. You understand? You have to allow, like you can't constrict the noise so much, right? So I'm going to do that. I'm going to come here and now will come here. I'll check the scorer, 0.168, right? So basically, from a business standpoint, they will always tell you that, hey, your noise should have plus or minus 2, 3, 4, 5%. They will always tell you that. Make sense? So people are raising up their hands. Afolabi, Shailon, any question?
Yes, there's question. So my question is, why is it that the normalizer apply is saying that normalizer value is out of bounds? What could be the reason?
Oh, why? Look at, it's telling you normalizer value is out of bounds. Why? Because the lower value is supposed to be -1, but there is a value. There is a value that is exceeding by a bit more than that lower value. That's just why it's telling you. It doesn't, don't worry, it's not your, it's because maybe some in Python calculation. It's just, that's not, it's fine. Because if you look at this number, if I use -1, it's approximately -1. So that's why it will still go through. It's not an error. It's just a warning. It's not an error. It's just a programming chemical. Don't worry. Don't bother yourself. Yeah. Ayobami, any questions?
Yeah, my question is one. I just wanted to show me how did you copy the thing and paste one and
Copy what? What did I copy? I didn't copy anything. Oh, how did I copy the workflow? How did I copy the
yeah,
workflow?
the workflow.
The node.
Yeah.
Oh,
Yeah.
okay. So I will just see my mouse. Can you see my mouse? My mouse is dancing on the screen. Can you see my
Yes.
mouse?
Yes.
Yes. I will just click on a point. And oh, bloody hell. I'll click on a point. I'll click on a point and select everything. Right.
Okay.
Or you can press Control and select 1, 2, 3, 4, all the things you want to copy.
Okay.
And you can right click, copy, and paste, or press Ctrl C and Ctrl V. That's simple.
Yeah. Okay.
Yeah.
The-
So that's that. Any other
the so what is the whole end point about this training model? Is it now we have a data set that is talking about price prediction for by giving some parameter.
Yes.
The at the end of the day, does it mean our model should be able to predict a correct price if we give him some certain parameter? I just want
Yes,
to know.
and those parameters, yes. If we give it some certain parameters, yes. How well can it predict the target value, which is the median value of the house? That is it. Yes. That's the goal of this. Yes.
Okay.
So for example, you are working with IoT signals, right? You are working with IoT signals for an appliance. Maybe you want to predict a fault, but you have the temperature sensor, you have the ambient relative humidity. You want to see the way the appliance will behave. So what you will do is you will simulate heater fault, you will simulate compressor fault, you will simulate door fault, you will simulate those faults. Take a lot of data about how the appliance is behaving when it has all these faults. Then you give it to a machine learning model, give it those sensor behaviors, see what is going to happen. Make sense? We'll talk about it later. Anna Duncan.
No,
Yes, you raised up your hand.
that was earlier when you answered me.
Okay. Thank you very much. Thank you very much. Thank you. Okay, so now that's it. The next thing that ended our class was how easy. So I'm just going to copy this and paste again. How easy. Ctrl C, Ctrl V. I'll drag it here. Now let's imagine I don't want to use linear regression. Let's imagine I don't want to use linear regression. Maybe linear regression was bad. I can also use a polynomial regression. I can also use a polynomial regression, where I take the data set, I take the knowledge, and I pass it. It's just the same thing. The same thing. You can see I've applied another regression formula immediately. You can see that polynomial regression is even behaving much more better. Right? You can see the error is 0.112. Right? So there are other regression algorithms. Linear regression, regression algorithms that we can quickly use, right? You just need to know how to use them. So we've tried it with, linear regression. We've tried the linear regression and normalizer, polynomial regression and normalizer. We can delete normalizer and see what the difference will be, right? What the difference will be. If you look at it, it is 2.52. So polynomial regression versus linear regression without normalizer, you can see that this is 2.52, whereas this is 3.6. You can see that 3.2 polynomial regression is better. Now, if I add normalizer and I run it, boom, boom, right? This is giving me what? 0.12. The one with normalizer, this is what? 0.16. So overall, polynomial regression is actually even better than what? Than linear regression for this. So as a machine learning expert, you will try different approaches, right? You've tried different approaches. Right? Am I making sense? Do you understand what we just did now? Hello.
Yes.
Yes, I understand.
We can hear.
Very
Yes.
good. Very good. So that just shows that we can try different approaches with very easy. See, I just did it in less than a minute, right? So now I know some of you will even be like, what is regression? Hey, this one that I joined this class, hope is not a mistake. No. We one way or the other, we've learned these things in school. Regression is when you draw all those graphs on X and Y axis or in your physics or in your class, and you're trying to find line of best fits. That is what regression is. In the world or in the business world, they try to predict the trend or predict things across many variables. In this case, we've applied it to predicting house prices. They just gave us small house prices. They want us to predict the one that what will happen in September or October. What type of house? They give us a house. They give us the attributes of the house. Can we predict the price? Is it going to be a cheap house or an expensive house? Make sense? Any questions? Okay, so that's regression. I know this class is sort of overloaded, but let's try something. Now, what if I want you to predict if the house is cheap or expensive? If the house is cheap or expensive, they give you this data. And they say, predict based on this mid value. Tell me if the house is cheap or if the house is expensive. What's the first question you ask me? Egbani. Nobody's talking. Yes? Someone raise up their hand. Meshach. What's the first question you ask me?
What's the average price of the house, I guess, in Boston?
What's the average price? Okay. Kenneth, what's the first question you ask me? I want you to tell me cheap house, expensive house. Hello, Kenneth, Meshach. Okay.
First thing I'll ask how much, and then I'll ask how much is it. Then I'll ask, is it in the high bro area or in the low bro area?
Somewhat both or everybody that talked are correct, right? What you just need to ask is, what is the definition of cheap? What is the definition of expensive? Right? So what does cheap mean? What does expensive mean? So say for example, I look at this table and I say, oh, median value, or this is the median value of all the houses. And I come here, I come to the statistics. Now, when I come to the statistics, the median value of the house is telling me that the lowest price of the house is $5 or five. The highest value of the house is what? 50. The smallest value is 5. The highest value is 50. So in my head, I will say that, if the value is less than 25, it is cheap. If the value is greater than 25, it is what? Expensive. Does that make sense? Hello?
Yes, sir.
How did you come up on 25?
Yes, it does. It does.
What did you say?
How did you decide to 25?
Because I looked at the value of the house and I saw that the lowest value is 5, the highest value is 50. So I just picked.
So you looked at the range, but you have the mean. Why don't you use the mean?
I thought you also assumed 25 to be the median value. Am I correct?
So what does mean? What does mean look like? What is the meaning of mean?
I guess I know mean has some error. Median might be a good one, but you don't.
Right.
I don't
So
see
what's
median here.
Let's look at the mean. The
mean is average.
The mean is 22,533. What if the people in that house are collectively poor? The majority of people in that house are collectively poor people, or majority of people in that house are collectively rich people? Maybe all of them just own rich houses by default, or big houses by default. So they will be, yes, that is a good attribute that majority of this house, so or majority of these people here, or just imagine you go to a place and 80%, 45% of the people there have $1 million houses. Does it mean that cheap means $1 million house? Hello? Hello?
I don't get
Does
your
it,
question, sir. Does it
so
mean
let's say you go to Ikorodu, right? A place in Ikorodu. But as local as the place in Ikorodu is, there's one small estate where everybody built 1 million naira houses, right? Is at those, and 40% of the people there have 1 million naira houses. Other people have 250, 350, 400, 500,000 naira houses. Is majority of the, and now when I find the mean of the house or the average of the house is about 990,000. Will I say that 990,000 means cheap or expensive? So mean there are some numbers that can bias the mean of a value. You understand? So say, okay, another example to give you is, say for example, there are 600 houses. All those 600 houses, the value of those houses are 100,000. 600 houses, all the value is 100,000. There's now one house that is 900,000. If I find the mean, does it show the average prices of the houses? Do you understand what I mean?
Yes, it's most likely to be very close.
It will be no.
It'll be off because of the outlier, because of the one
Because
number.
it's a bias. So if I say there are three values, 100 plus 100 plus 100, right? If I find the mean of these values, right, what will it give me? Divided by 3. That will give me what? 100. Now let me make it 6. I'll make it 6. Right?
Okay.
It's what? It's 100. But let's assume that one of those houses is now 100,000. What's the mean? Does it mean that the mean of the house is 1,750? Oh, sorry, it's even 10,000 I put. Does it mean that the mean of the house is 1,750? No. Do you understand? This just means that houses less than or equal to 100 are cheap. Houses greater than or equal to 10,000 are expensive. Do you understand?
Something. I got mixed up on something.
What did you say?
I said I got mixed up on something. Now your illustration is very apt, but I think I got mixed up somewhere.
You know where?
You use six examples of 100, then just one of them turned out to be maybe 1,000.
10,000. Yes.
Oh, 10,000. So if we now find the mean of all those, I think it will give us, let me see, that's
1750.
That's 1750, 1,750.
Yes. Does it mean that majority of the house are 1750? No.
No. Okay, I get it now.
One value can bias your mean.
I think mean deviation. If we have the value of mean deviation, it can help us in the.
It can help us. Mean deviation, standard deviation, all those statistical attributes. Yes, they can help us. Yes.
No, be able to predict better.
Yes, and I agree with you, right? But we will go. There's another class for that. We're already going into features engineering, right? But don't worry, just let's know how to be very comfortable making models. If I say right now, Ugo, give me 25 models and tell me the best one. Oh, no problem. In less than 25 minutes, you will come back with 50 models. I'll say bravo. Right? Meshach, can I answer the question?
Yes, sir. I didn't want to interrupt you while you are already on another class. Yeah, thank you. I just want to see if it is possible, if you can quickly review the partition. I just want to see how you configure the data.
So it's just one
from
click partition. Whatever is here,
yes.
so 75%. So it will split. The top partition will be 75%, while the rest will be 100 minus 75. Is that simple?
Okay, under first partition. Okay.
Yeah.
Okay, thank you, sir.
No problem.
Then
so that's
on the issue of hello, sir. On the issue of mean, sir. Yeah, I think from flashback we understand that mean sometimes usually have problem because of outliers. So if you have domain knowledge of that feed, that will also help to determine what is an outlier. So I think the problem is outlier, which is not good for us to use mean to actually use mean value to actually say if something is this or not.
I agree with you. Thank you. Don't worry, we'll get there. Kenneth, you raised up your hand. Okay. Josephine.
I don't have a question. Mine's not raised.
Okay. Donkanana. You raise up your hand.
I don't know, because I think you're still seeing the one from previous.
You know, is the machine is like, I think the machine is sensitive. It knows you are supposed to have a question. You are supposed to have a question, but you are not asking. Don't worry. Next week you come. Then everybody will come. I did not download. I was watching your video. Know that I've heard all the excuses. You get, I've heard it all. No excuse. You can come next week. So now let's quickly because I don't
sorry
know.
Sir. This sorry.
Sorry, ma.
Sorry. Yeah. So what's the best way to determine the average price? Like you said, using mean.
So like someone said, you domain I was saying that to convey another knowledge for your assignment for today. Don't worry. There's no best approach that I'm teaching you now. There's no best approach. I just want to teach you something called rule engine. Right? So I'm going to teach you something called rule engine, right? It's a way to add columns. So let's say I had this data. I take the data, right? I now configure the rule engine. What's the rule engine? The rule engine is telling me that I will take medv, right? Medv is the value I want. I will say that if it is less than or equal to 25, that's how they did it. Yeah, less than or equal to 25. I want you to create a column and write that it is what? Cheap. Can you see it? That's that. I'll take it again. That's one rule. I'll come again. If it is greater than 25, I want you to write that it is what? Expensive. I want my land.
Expensive.
Right? Simple. And let's see what will happen. I will apply it. And okay. Look at what the rule engine, and I will run it. See what the rule engine has created. The rule engine has created another column to say cheap, expensive, cheap, expensive, cheap, expensive. If you look at the statistics, now we have something called string. You can see that it is not in numbers, it is in letters. The data type is in string, right? It's not numbers. We don't have maximum, we don't have minimum. The unique value is 2. So I'm creating a discrete value, a classification of 2 values. It's just 2, cheap and expensive. Cheap and expensive. Now, there's another regression algorithm that can predict that stuff that is not numbers, that is words. It's called logistic regression. Logistic regression. Right? It can predict words, not necessarily numbers. So what do I mean by that? So these house prices, I've predicted them into 2 classes. Those 2 classes, we have moved from the concept of regression to classification. So the houses that were predicting the price, we're now predicting into two classes. A class can be boys and girls. Class can be dogs and cats. Class can be cheap and expensive. So we've done regression. Today, I was supposed to teach you classification. So we have to touch it, right? Classification, regression, and then we need, oh, sorry. When we come here, regression, then we will partition. Yeah, we'll partition into, this comes here, this comes here, regression linear. You see, sharp, gang, and then what do? We run it. Yeah.
Someone said the message, sir, that session has expired. I don't know what that means.
Who said that?
I saw it on the group. Session has expired.
No problem.
On the Telegram, Pastor Shoyemi. I don't know what it means, but let's continue.
Okay. And what did the regression learner tell us? The regression learner provided a prediction. So when we said cheap, it saw cheap. Expensive. You can see that this prediction is, you can see this place, it was wrong. Expensive, it predicted cheap. Expensive, it predicted cheap. Right? Cheap, expensive, right? Expensive, right? So these are predicted words. This is classification. We have tried to bring in classification into this regression. You know what I'm saying? Right? So now, how do we evaluate classification? Right? How do we evaluate classification? We evaluate classification with confusion. Hold on. Wait a minute. Just give me 1 minute. Yeah, okay. So in classification, in regression, we have numeric scorer. In classification, we have something called scorer. Right? Scorer is going to check and say, we are doing prediction and prediction. I should have changed the name. Right? So I'm going to come back to this rule engine. I'm going to configure so that it doesn't confuse us. So the new column that we want this rule to apply, we can say house class, right? Yes. By the time I run it, it's going to give me something called Medvi house class, cheap or expensive. It brought it out as prediction. So I don't want it to confuse us, and then everything will go. Okay. House class. Okay. Yep. And then I take this. Yep. Please, any question? House class, prediction, house class. Yeah. Yes. Any question? So when I come here, it's going to give me something called a confusion matrix. It's going to give me something called a confusion matrix. Now, this model is very bad. Very, very bad. Do you understand what this confusion matrix means? Who understands it? Mudari. Can anybody hear me?
We can hear you.
We can hear you, sir.
Now, you can see that we've done classification, right? We've done classification. And we've created a model for classification using logistic regression. It's just the same way. We took the syllabus, we applied a rule to make it into a class, and then we partitioned it. And then because we know logistic regression is for classification, and this is the student, and we are scoring it. Now, in the scorer, this is the accuracy. It's telling us that the overall accuracy is 53%. the overall accuracy when he was doing cheap and expensive is 53%. You know, this is naturally a regression problem that we converted. But this, I just wanted to portray that this is how you convert it. This is how you convert it, right? So far, any questions? Anybody, everybody?
You were asking about interpreting the confusion matrix. Can you go back to that?
Yes. So now in the confusion matrix, why is it 53%? Why is it 53%? Now, this is saying that if you look at the axis here is what? The axis here is what? Cheap and expensive. The columns here is cheap and expensive. So what does this mean? In this confusion matrix, it's saying that the model saw cheap, and out of all the images it saw, it was able to accurately say that 46 of them were cheap, and truly 46 of them were cheap. But he saw another additional 69 as cheap, but they were actually expensive. So this 69 is, this place is supposed to be 0. In this expensive, he saw 2 images as expensive, but they are actually cheap. But he now correctly said 35 of them were what? Expensive. So there are some numbers that it is gauging that is it cheap, is it expensive, is it cheap, is it expensive, and it is confusing, and that is why the accuracy is what? 53%. Am I making sense? So if you look at it, the true classification, the true positive, 46 and 22. The one that he truly got correctly is 46 and 35. The one that it confused is 2 and 69. You understand? And that led to this accuracy. Am I making sense?
Yeah, that makes sense.
Yeah. Okay. Any questions? I know there's a level of information overload, but that's why some people are new. We had to, start the class from scratch, stuff like that, right? And we did not even finish today's class. Today's class, we're supposed to go into use called, and since I already have taught you, all right?
Sir, please, can you go over how you configure the linear, the logistic regression and the predictor, the logistic regression, the configuration.
So before you go over, something is confusing me.
The confusion makes it.
I'm trying in my mind to compare the manual, let me call it manual, the manual example you gave before on this same question. You gave a condition that if, that's the first one, that if any house that sells for less than, was it 25?
Yes.
Is cheap. And whichever sells is expensive. And with that, able to give us cheap, expensive. But when you now run the model, I'm now seeing that some that were formerly cheap are now expensive.
No,
so what is
look at, there are 2 columns. There are 2 columns.
Yes.
There are 2 columns. This is the one that came out from that row. But this is what your model is saying. So your model did not perform well on many.
Okay.
So this is just showing that your model right now is terrible.
Okay.
But understand, we are not this exercise right now is rushed. I'm teaching you how. Now, to get a good model, we're not going to delve into it like, okay, let's say we have this now. This 25, there's no rationale behind it. This 25 that I put, there's no rationale behind it.
It was arbitrary, yes.
It was arbitrary because I just want to teach you how it is.
Yes.
Do you understand? This may give a more correct answer, maybe less than 25, less than, greater than. It may give a better answer. We don't know. Right? Okay. You can see it actually gave, what's the accuracy? 73%. It may give, but what I'm just trying to get at you is that convey to you is that I just gave you an example of how it works.
Okay.
Do you understand? That's the goal of this. Do you understand? So a time will come where you will have to experiment how to actually build an intelligent model that will give you the best accuracy you want. Am I making sense?
Okay.
Yes. I pasted a link to Irish dataset, right? Irish dataset is very similar to this. It's very similar to this. But that would be your assignment. Okay? That would be your assignment. So it's just the same way you will come, you get a CSV reader. You get a CSV reader. The data is in CSV. This is the link. The link will give you here. You download the data. When you download the data, you download an archive document. The archive document will drop down. If you open it, you see irish.csv. Irish.csv, right? And you configure. Ulrich, are you there?
Yes, I am here.
Ugo, are you there? Ugo has gone.
Yes, I am.
Okay. So you can see Irish data sets. This is supposed to be your assignment. You use so when you run it, you can see now these flowers. It's just like, look at a leaf. It's a leaf. They are giving you the length. They are giving you the width of the sepal and the petals, right? Now they are now. This is classification. There's Irish setosa, Irish versicolor, and Irish virginica, right? 3 colors. If you go to the statistics, there are 3 classes. You can see it's 3 classes there. It's a string, 3 classes. How can you predict the 3 classes, right? How can you predict the 3 classes? So what are you going to do? You can just take all this, Control C, right? You partition it. When you partition it, then you run it. Yeah. Logistic regression is telling you what should be the class. What is MEDV? No, sorry, it's because I copied and pasted. It's having some issues. Right, so logistic regression, fresh one. You know, I did not normalize, I did not do anything. So during your assignment, you have to apply different concepts to make sure that you know it is looking good. Yep. Yeah. Prediction spreadsheet. Okay. Now look at it. You can see this one is because we are doing 3 things. If you look at the accuracy is 84%. It's a good model from scratch. It's 84%. And look at the confusion matrix. It's saying that Irish setosa, right? Out of all the data set I give it, it got everything correct except one. It got everything correct except one. So out of the 15, it got 14 correctly. In Irish Verticolor, it got everything correct except 2. And in Virginica, it got everything correct except what? 4. So, and that's why it has an accuracy of what? 84%. Right? So I have introduced classification to what? To you. Make sense? Make sense? Hello?
Yeah.
Yes.
You can see how easy. So that's why the foundation is very important. You can see how easy I've introduced classification to you. We've done regression. Now we've done classification. Am I making sense?
Yes.
Some of you are tired. You are sounding tired. Yes. You are just yes. Nobody's asking yes. You are tired, Abby. Don't worry. It's fine.
Yes, you are not tired. We are We are absorbing
we are trying to follow through.
I'm trying to absorb this.
What we just did now, Said, did it make sense to you? Said, are you there? Said has gone. Obinna, are you there?
Yes, I'm here with you.
Yes.
It makes sense.
Did it make sense to you? Very good. Obinna, you are raising up your hand. Emmanuel, Obinna, you can talk. Oh. Josephine, heartbreaker. Is it making sense to you?
Yes, it does. But I'm not wondering the assignment. You've already done the assignment.
Look at you. Very good. I like Josephine. So what's the assignment? Me, as haphazardly as I did my own, my accuracy was 84%. You have to do your own to make sure it is 99%. That's it. That's what I don't want anyone that the accuracy is less than 95%. That's your assignment.
So how do we submit it, sir? How do we submit the assignment?
You will write your name, take your screenshot, and paste it. And anybody that submit on the day, you are out of the competition. If you submit on Saturday, I've done it, and you submit on Saturday, you cannot win the cash prize. It has to have been before Saturday. So 12 on Friday is the submission deadline.
Why not make midnight?
Able to get
That's what I'm saying now. That's what I'm saying. 11:59 on Friday.
Okay.
Is it Eastern time, Central time?
11:59 West African time.
Mountain time.
West African time. 11:59 watts. So some of you on Eastern time, that is by 4:59.
That's not balanced. Our time has already started.
What about the link?
What about the link? It's on the chat. It's on the chat. You have no excuse. If you watch the video, you can copy the link. It's on the chat.
I've not seen the link on the chat box.
Very good. Hold on. It's two assignments. 25K. It's two assignments. Hold on. Let me finish. I planned well for you people to, but you people just took me back. I want a classification. I know. Don't let me call you. Hey, something. I want a regressive classification because let me tell you something. When they throw you, I'm teaching you all these concepts, right? You don't know the job you will have or the thing you have to do, and you don't know how complex it is. That's one. There is no one approach to the right answer. You have to try all of them. So they give me this Irish data set. Just follow me, please. Follow me. Go. Yeah. Now I want you to follow me and indulge me in this. Look at it. Iris setosa, iris kinikon, right? I want to do something. I'm going to apply a rule engine. I'm going to apply a rule engine. I'm going to pass this here. The rule engine. And I'm going to come here. I'm going to delete it. I'm going to say specie. If specie is equal to Irish setosa, right? No. Okay, yeah, this is a good way to teach you guys this. Let it be equal to 0. Right, setosa. Right. I'll put it and I'll paste it. If specie is equal to Iris verticolor, let it be 1. If specie is equal to what again? Virginica. I'm surprised I remember all these things. Let it be 2. Right? Let me run it. So you can see, exactly, see, I missed it. I missed the spelling. I probably missed the spelling. Irish dash Setosa. Irish dash. I got it now. Setosa. Verticolor. Verticolor. Got it now. So what is the problem? Especially okay. Yeah, no, especially yeah, correct. Especially equal to this. I was trying to teach you append column. Okay. But let's see. Yeah. Okay.
Sorry, can we access these data sets from the same platform, Cargo?
Yes, category number. Okay. So I was trying to teach you that this rule engine, right? Instead of me to be writing rule engine in this approach, where I have numbers, if I want to where I have words, if I want to convert them to numbers, I can use something called category to number. Category to number, right? And if you look at category to number, it has turned Iris Setosa to 0. It has done Verticolor to 1. It has turned Virginica to 2. Can you see what it did? Am I making sense? Using this category to number, it will convert everything to 0, 1, 2. Now remember, what did I say? I want you to do a regressive classification. A regressive classification. So instead of this, I will yeah, I'll come here. I will take a column filter. This is your assignment, so you go and study it. So now, if you notice, specie, I want to remove specie because I have converted specie to a number. I don't need specie anymore. That's why I'm removing specie, right? So column filter is it will exclude some column and include some. So in this one, in this column filter, if you look at all those verticolor, they are out there. Then I will partition it. When I partition it, I've partitioned it. But instead of a logistic regression, I want to use a linear regression. Because now it is already numbers. I can take a linear regression predictor, and then boom. You know, the other one gave us 84%. Let's see what this will give us. What happened? That sounds like Josephine voice. Josephine, what happened?
I didn't say anything.
Yep. Now look at, see what I'm getting. The accuracy is 0.12. Look at what it's predicting. Instead of 0, it's predicting 0.19, 0.19, 0.19, 0.19. Instead of 1, you can see that it's predicting something that is approximately equal to 1. You can see that we can use regression for classification. Are you listening to me? You can see that instead of 2, it's predicting something that is almost approximately equal to 2. Okay. Am I making sense? Oh God. You people are not seeing the Rema. Jesus.
Yes,
hey,
commenting.
You are not appreciating the appreciation. God damn it. You can see that instead of take this. So let's take species and prediction species. Let's see it as a line, right? And then let's run it. You can see that it is following the line where it was 0. Yes, it is not a perfect 0. It is not a perfect 1, and it's not a perfect 2, but it's approximately 2. It's approximately 2. If I approximate it, it's 2. right? So you can see that in some cases, normal classification may not work. In some cases, normal regression may not work. In some cases, regressive classification. This is called regressive classification. Do you understand? Because in many cases, where it is 0 is approximately 0. Where it is 1. So that means that I can create a rule. Just imagine, I can create a rule. I can create a rule. Sorry, this is the last thing, and then we'll just gist and go question and answer. I can create a rule and say that, oh, in this rule, if this prediction is less than 0.5, let it be equal to 0, right? Right? Less than, yes. Now, if the prediction again is greater than equal to 1.5, let it be 1, right? If it is what? Less than 1.8, let it be 1, right? If it is something is wrong. Okay. I know what I did. I don't know what I did wrong. I know what I did wrong. Right? So if it is less than 0.5, let it be 0, let it be 1, less than 1.5. If it is greater than 1.5, let it be equal to what? 2, right? Let it be equal to 2. I can do that, and I can run the rule engine. So look at it. 0, you can see I can skip this one. This one, I've applied rule engine on this column. 0, 0, 0, 1, 1. But now look at some errors. 2. What the hell? Hold on. It's supposed to be 2. This is 2.12. It's giving me 1. If it is less than this. Oh, okay. Okay. If it is greater than hold on. And less than 1.5. Can take this away. But do you understand what I mean?
Yeah. Yeah, we are following.
Hold on. See. Okay, perfect. Yep. Let me now pass this to the line graph. Yep. And come here and say take this away and send this back, and then okay, and then see the graph. You can see is exactly on top of each other. Can you see that it's exactly on top of each other? Hello.
Yeah. Wow.
Now let me make your assignment more complex. Let me make your assignment more complex. I'm going to do. You can see I did category to number. Let me now convert number to category. Number to category. Number to category. Right? Number to category. So you can see category to number. I'm going to come here. I'm going to take it. I'm going to take this here. It might be no. I know it's looking somehow, but it's not my fault. Number to category. Let's see if it will get it. Eh? No. Sorry. Number to category. Category to number. Category to number. Apply. What the hell is number to category? Category to number to category. Category to number. Apply. Where is the category to number itself? No worry. We have ended. Don't want to use the rule engine. I don't want to use the rule engine. Let's just. I just need to just put the icing on the cake. The rule engine. So I'm going to come here. Let's come here. I'm going to take this prediction. If prediction is equal to 0, if it's equal to 0, then make it Iris, Setosa. What I converted it to category. I want to convert it back. That's why. 2, 3.
Converted it to numbers. Converted it to numbers. I want to send it back to category.
The color, then Iris, so that we can do the Virgin. We can do the confusion matrix and get the accuracy Virginica. Right, apply prediction category. Apply, go, run. So you can see. Don't mind. I'm taking everything back that I've done. Yep. So if you look at it's a number. So you can see it's Setosa. You can see the long journey, right? So I'm going to come in. I'm now going to add a scorer so that we can see the confusion matrix. It's between prediction, category, and species. And then boom.
This one is perfect.
No, it's not perfect. I made a mistake. So you can see it's verticolor, Setosa, versicolor, Virginica, Setos. Okay, it's my mistake. So this is supposed to be Iris. It's supposed to be 3 Iris, and versicolor, right? Okay. You can see it's supposed to be 3. So what's the percentage? What's the accuracy? The accuracy is 100%. Can you see? Compared to this accuracy, when we use classification, the accuracy was what? Where is it? The accuracy was 84%. You can see that without even adding normalization, I'm getting an accuracy of 100%. 100%. Eh?
Is it not cramming?
Is it not cramming? We don't know. Now, is it not cramming? Yes, it may be cramming because the number of data is very, 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 very cheap, very, very small. And I used a complex mathematical classification approach. I merged two concepts together: regression and classification. Right? I converted the classification problem into a regression problem. Then I now classified it after. Right? So now it may be because I'm too good or that the model is cramming. But do you understand what I'm saying? Am I making sense?
Yes.
Am I making sense? So don't just think about this problem. Think about what we can achieve. Now, some of you may say that, oh, all this work, this, if you're in an office, just walk up to your teacher Walk up to your walk. I said, walk up to your teacher. Walk up to your secretary. Walk up to your boss. That, so I'm doing one boot camp. I really want to see if I can analyze the business and see where we are, where I can save you money. Look at the data sets and run it. Just run all the features and see what we want to predict. Let's predict all our wastes. Let's predict where we are losing money. Let's predict something, and go and take the graph to your guy at the end and say, I can save us money. These are the top reasons why we are losing money. Do you understand? It's something we can do, right? It's something you can do right now. So I've taught you classification. I've taught you regression. I have taught you regressive classification. Hello. Are you people not excited?
I do.
So this is where we will stop today. I hope next week, Josephine will have watched the videos. Mishak will have done everything, and that, and this and this. I know Josephine will be like, this man, you leave me alone. Josephine, you broke my heart. That's why. The last game that broke my heart.
You think where did all the work and it's showing 100%? Is there a rule that we are not supposed to use this same method that you used?
Don't use my method and get 100%.
But it's the same, like regressive classification is it follows the same flow, like using converting it to numbers.
Just imagine, look at the way Josephine is talking. I like that confidence. Imagine that you now get to the office. Sir, have you tried machine learning? Because a concept of regressive classification can help us standing inside into this data so we can make data. Just imagine you are talking. Those are the kind of people we want to raise. You're not tapping into my ginger. Not coming to pastor. But yes, I understand what you're saying, that I've done the assignment. I got carried away. I was excited, But you just, I'm going to send a new data set.
Okay, sir.
So we have a new data set. Don't worry. Share is data set that is doing no problem. I'm giving you penguin data set. Penguin data set. You can see my screen. We have penguin data sets.
Right, sir.
We have done so penguin data sets. Either use regression, polynomial regression, any of the regression, anything. The person with the best accuracy wins. And the accuracy can be to the nearest 10 to someone can have 95%, and someone can have 95.55%, or 96.3, or 90. Person with the highest accuracy. Am I making sense?
Yeah. Yes, sir.
I have drained a lot of you. You are tired. Sorry. So for those that are new, make sure you join the class, watch the previous videos. They are just to reinforce what we've learned, and also the diamond data set. The diamond data set. This was the data set that I used to give them assignments. That they did not do it. That's it right there. PS. Oh, Palmer Penguin is too popular. PS. Right? If you don't do your assignment, you cannot qualify for the competition. If you don't do your diamond assignment, you qualify for the competition. Okay.
So can I ask a question? This link to the class, because I saw a link there, is saying class code. What is the class code?
I will get you. Hold on. They said someone said Palmer Penguin is too easy. What of Titanic? You know what? Let me just be terrible. Let me just be terrible. Let's see what the data set looks like. Let's see what the data set looks like, and then result you. Okay. Very good. Very good. You can see it. Less than 50K, greater than 50K, less than 50K, greater than 50K. Very good. I think you are supposed to predict. So I'm going to give you, you can see that it is numerical, divorced, married. It is categorical. This is, whoever said that penguin is popular, God bless you. This is the data set. Very good. Very good. That's your new assignment. Don't do penguin. Nobody should do penguin. If you do penguin in this class, I will banish you. That's your new
Can
assignment.
you help with the class code?
Class code. Let me see.
I think that's where we can see the recordings, right?
Yeah. Let me see. I think this is the class code. Wait, is this not the class code? Let me see. Let's hope so. Let's hope that's the class code. Yeah, join the class code. So, any questions? I'm expecting, I know I did a lot. I know I rushed you people a lot. Nuruddin, Balogun. Is it Balogun? Nuruddin, any question? Joy, any question? Josephine. And if you miss next class, Josephine, if you miss next class, don't join again. Any question? And Jory.
Okay.
Yes.
So the thing is not, the code is saying is 7 characters.
Okay. Well done.
Maybe I'm in the wrong place. I don't know.
No, not necessarily. I think I don't know the code. I would have given you the code. I'm just shooting darts in the dark. Oh, okay. This is the code. Sorry. This is the code. I'll find the code. So now, all those without class code, you have a range from 5 to 50 in regards to price. Okay, sorry. That's the code.
All right.
So, I know we did it now all the time, but it's over the class. Any questions, everybody? Any
The
questions?
assignment, what data are we predicting? So I've not opened the data set.
Have you clicked on the link? This is the link.
Okay.
This is the link here. You are supposed to about the data set. Yes. You are supposed to predict. This is it, right? This is the data set actually. The details. So I think you are supposed to predict their income. So there are 16 columns. This should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 16 columns, and the columns is their age, their working class, their education, so marital status. Let me give you this so you can read the description. To predict the adult income. I'm going to write a full description of the assignment in the slides. So I want you to predict regression to predict the income. I also want you to predict a class if they are rich or poor. If they are rich or poor, I want you to predict a class. So there will be 2 things you will give me. But remember, if you don't do the diamond pricing, you don't qualify to do the assignment. You have to do the diamond pricing and you have to do this assignment. Right? So, any question?
I think we just outline the questions for this assignment. So,
okay, so that we are all on the same page.
Yes.
We are all on the same page. So yes, classification. This is what I was supposed to do today. Under classification, we are under machine learning algorithms. We have supervised regression and classification. We've done regression. Now we did binary classification where we are just classifying two things, cheap or expensive. We did multi-class classification, which is iris setosa, iris verticolor, iris virginica, where there are more than two classes, right? We've not done this one. So, and what is classification? Classification is just trying to distinguish between discrete classes. Regression is trying to find line of best fits, right? And this is what it is. The data, they had labeled it into iris setosa, iris verticolor, and then we train the data, we predict the data, right? Cats and dogs, whatever. So we will still do image classification, but we are still doing numerical classification. So assignment. Let me just copy this one. Look at them. They are saying I did not give them assignments. See the assignments here, boldly written. Don't worry. God will judge. It's all of us in this country. Assignment, right? The first assignment is that you come here and you take adult income. Yep. Send link. So the assignment will be on the class notes. Right. You can see you're also supposed to prep your document for KRAS, but nobody did it. No problem. So your first assignment is make sure you do the first assignment. That's your first assignment. Your second assignment is using this link. Using this link, predict the what? The income or predict the income, right? Let me see. Using the annual income results with individual annual income. All right. Predict the individual annual income. The hell?
So what I'm seeing here, the dates for the last class recorded is in 2023.
Maybe it's me that use the income.
Then you also said we should classify something, sir.
Ta-da. So that's the assignment. Are we good?
Okay, let's see. Predict the new use income column to classify. Okay.
Okay.
So, okay.
I'm going to get the this is called 2. Hold on. I'm coming. This is called 2. This is join. Nope. This is join view. I'm coming. Yeah, I've got 2. Some of you, Meshach, I'm seeing your name here. Can you get us? You know what the code is for this class? I'm trying to see if I can get the code for this class. Nope. I'll get it to you, Google. Okay. So, any other questions? Are we good? So, in the absence of no questions, please, everybody, this is not Sunday service. Make sure you go home, you practice, you dwell on it. That's how you become good at it. Afolabi, I know you did your, is it Afolabi or Ayobami? One of you, I know you did your assignments, but because of the class, we had to talk through, but we'll study all the assignments next week. Said, you raised up your hand.
Totally thank you for this lecture. So if I needed to access the previous videos and this video, how can I do that? And also the deck, how can I have access to those decks too?
It's going to be in the classroom data like this one, right?
Okay. I don't think I have access to that.
I'm going to I've sent the link, but I need to get the code. I'll get the code and I'll send it to you.
Okay, good. Thank you.
No problem. So, any other questions? Thank you very much. Today was very consuming. There is some risk of information overload. I understand. I apologize. In short, you apologize to me. That being said, we need to band together and study. I have not yet seen the hunger. I know many of us here are Jebota, but I've not yet seen the hunger that we want to be machine learning experts. I hope by next week, all of you will change my output to you guys, right? So, but don't let me keep you waiting. I don't want you to spend any more of your time. It's been 1 hour and 2 minutes extra. I appreciate everybody that waited. Thank you very much, everyone. Is there any other question? No. In absence of no question, thank you very much. Thank you, everyone. Have a lovely weekend. Oh, there's a question. Adoga, you can unmute.
I'm going with you. If we have questions, as we are practicing, I want to ask you more questions.
Just drop message on Telegram and on the classroom. Last week I was indisposed, but I should attend to them. Okay. On Telegram and on the classroom group.
Right.
So no problem. Thank you very much, everyone. Thank you. Take care of yourself. Have a lovely, lovely weekend and invite your friends over. But if you're inviting any new friend now, make sure you teach them or send them the videos. All right? No problem. Take care of yourselves. Bye-bye.
Thank you. Bye.
Okay. Bye.
Please send the code. Thank you. Bye.
I will. Bye-bye.